बच्चों let us see in this example a very interesting example of friction. One plank is there of length L, mass capital M, and a smaller block is placed on the plank on the left side. Now the coefficient of friction between the plank and the ground is mu, and the smaller block and the plank is mu by 2. Obviously, when this system is given v velocity in rightward direction, we will observe that the frictional force will act at the bottom plank bit and ground. That will be more frictional force will act. Why? Because coefficient of friction is more. Here less frictional force will act because coefficient of friction is less. So obviously the frictional force will act in this direction and it will be more accelerated in leftward direction, and the smaller block will be accelerated less in the leftward direction. With time, what will happen? After some time, this block will fall down. This will be accelerated more. It will be accelerated less. So with time, this block will come on the right side and it will fall on the right side from the plank. So let us find out what time it will take to separate from the plank. The smaller block, what time it will separate. So very simple. This example is very simple. I can find out the upper block acceleration as in this direction. I can write the frictional force is acting mu by 2 mg. That should be equal to mass into acceleration. So mm gets cancelled. So I can write a1 is nothing but it is mu g by 2. Similarly, I can find out for the plank the free body diagram. The frictional force will act leftward direction. That will be mu times m plus m g, and in this direction the frictional force will act as mu mg by 2. So I can find out the net force in this direction is equal to mu m plus m g minus mu mg by 2 equals to mass into acceleration. So I can find out A2 as equal to mu g m plus m by m minus mu mg by 2m. Now obviously this acceleration will be more, so I can find out the relative acceleration AR as equal to A2 minus A1, and that can be written as mu g m by m plus mu g minus mu g m by 2m, and then minus A1 is mu g by 2, right? So this expression we can find out mu m g by 2m plus mu g by 2. I can take mu g by 2 common. Mu g by 2 can be taken as common, and this comes m plus m by m, right? Now I can find out the time in which this block will separate from the plank is equal to root 2l by AR, and that can be written as root under 2l. AR is mu g by 2 m plus m by m. So I can take this in numerator. I can write 2l m, and 2 will become 4. So this is the value of time in which it will be separate from the lower plank, lower block. So let us see this example is very. Now one more thing I will tell you, that if the coefficient of friction is changed here, suppose I change it from mu by 2 to, let us say mu is coefficient of friction between smaller block and the plank, and the mu by 2 is between plank and the lower. In that case, what will happen? So I will just simply explain you. If this is the situation, this becomes mu and this becomes mu by 2. So you will observe here now, and the system is given v velocity. You will observe this will be less retarded, so less accelerated. This will be more accelerated. So the moment it is given v velocity, this will fall behind. So it will immediately separate from the lower block. Now in that situation, if this block is not at left end, but this block is at right end, let us say at right end, then what will happen? This will be accelerated more, this will be less. So after t time, it will fall down. So same way you can find out the answer for time, in what time it will separate. Thank you. Please do not forget to like and subscribe my channel.